Hi there, welcome to Machine Bytes, your go-to place to learn AI the smart way. Today's topic is measure of dispersion. Dispersion describes the spread variability of dataset. It tells us how much data points deviate from central tendency. So if I take example, if we have some data where our mean value is 5 and data is going till 25, say here, and minus 25 here. So this is the spread of data. But if we have another data where the mean is 5 and the maximum value is up to 20, and on this side the maximum value is up to minus 15. So in this case, the data is less deviated from the mean. There are different measures of dispersion. One of them is range. If we talk about this example itself, then the range will be 20 minus 15. That is maximum value minus minimum value. So here the range will be 45. The other measure of dispersion is variance. Variance is average squared deviation from the mean. It is denoted by sigma square and its formula will be summation of square deviation from the mean. So if xi is the point, its deviation from the mean, we will take its square and then divide by number of points. This is called population variance. We have sample variance also, which is denoted by S. Its formula will be summation from I to small n, then deviation from the sample mean divided by total number of entries in the mean minus 1 and square of this term. You might wonder why we are doing minus 1 here. This is called Basel's correction. This is added to get unbiased estimate of population variance. It was proved by an experiment that if we divide sum of deviation from sample mean by n minus 1, in that case, we get more unbiased results. The other measure of dispersion is standard deviation. Standard deviation is derived from the variation only. So if we talk about population standard deviation, its formula is square root of variance, and this is denoted by sigma. Sample standard deviation is denoted by S and its formula is square root of sample variance. Now, since standard deviation is derived only from variance, why should we use that? Because in standard deviation, the output value is in the same unit as of the dataset. And because of this, it's easier to interpret. Let's take an example. If we have data like 5, 10, 15, 20, and 25. For this data, our mu will be 15, which is also called population mean. Now, to find out population variance, which is sigma square, it will be 5 minus 15 square plus 10 minus 15 square plus 15 minus 15 square plus 20 minus 15 square plus 25 minus 20 square divided by total number of entries, which is 5. And it will be 100 plus 25 plus 0 plus 25 plus 100 divided by 5, which will be 250 divided by 5, and answer is 50. So for this data, our standard deviation will be the square root of variance. Now square root of 50 will be almost 7.01. This is our standard deviation, while this is our variance. Now we can see that standard deviation is in the same scale as of the data points, while in variance we have kind of squared value. So it's difficult to interpret the results here. The other measure of dispersion is IQR, which is interquartile range. IQR is the difference between 75 percentile and 25 percentile of data. If the data is divided into 4 parts, then Q1 is 25 percentile, Q2 is 50 percentile, and Q3 is 75 percentile. So if our data is something like this, 50, 75, 100, 25, and 0. If values are between these values, then our Q3 will be the data from here till here. This is the range of Q3, while Q1 is this 0 to 25. We will find the difference between these and we'll get this range, which is called IQR. Now the formula of IQR will become Q3 minus Q1, which is this portion. Using IQR, we can also detect the outliers in the dataset. For that, we only allow values from Q1 minus 1.5 times of IQR to Q3 plus 1.5 times of IQR. So anything beyond this will be considered as outlier. These are the major statistical methods to analyze the dispersion in the data. Let's see where all these can be used. As we discussed, this can be used for outlier detection. Then, to understand the data distribution and for feature scaling, variance is generally used to scale the features for model evaluation also. This is all about this video. If you have any suggestions, questions, please let me know in the comment section below. Thank you so much. Bye bye. Take care.